Hello class, I'm working out of your Algebra 2 book 7.1, Simplifying Radicals. Later we will do number 14 and 34. To get started, we'll be thinking about not only square roots, but also cubed roots and fourth roots. So to get started on just thinking about what we know with square roots, we have the square root of 100. We know that is 10. But in a cubed root situation, we are thinking about what number multiplies by itself 3 times to get back to the value under the cubed root symbol. In this case, it would be 5. And in the fourth root of 16, in this case, it would be 2. We can have negative values under our root symbol. So if we have the cubed root of negative 125, then because our index is odd, a 3, we can say our value is negative 5. Look what happens here. We have an even index at 4. If we make this a negative 16, negative 2 times itself 4 times is a positive 16. And in this case, because of the even index, there's no real root. We're going to have to factor out some information and just go out and grab some values that will help us factor with variables included as well. So let's think this through. Our goal is to make our exponent be divisible by our index, and then we'll have some external values that will come out of that when we factor, but that's okay. So what does that mean? If we go out and grab a value for 192 in the cubed root, we need to think kind of small. And if we think about 2, how close can we get that 2 with a larger exponent to 192 times another value to make it come back to 192 and be divisible by our index number? Well, we can break this apart into these parts. If we take 2 to the 6th power and multiply it by 3, then we have 2 parts that comes back to 192. We take our a in the cubed root to the 3rd power times a to the 2nd power in the cubed root. 3 plus 2 is the 5 exponent. And if we take the cubed root of b to the 9th power times the cubed root of b by itself to the invisible 1 power, so to speak, then we came back to the b to the 10th power. So just going back over, work this out in your margin. To get back to the 192, excuse me. So you're trying to get your exponents to be divisible by your index, and then what is left over we will address shortly. So 6 divided by 3 here is 2. That leaves 2 without the root symbol to the second power. We are still going to have the cubed root of 3 left. 3 divided by 3 here is 1. So it leaves a by itself. We can't do anything with this, so we leave it in the same format. 9 divided by 3 here is b to the third power. And we can't do anything with this at the end, so we leave it in the same format. Now we can address these values outside the root symbol. 2 squared is 4 times a times b to the third power times the cubed root of 3 a squared and b. This is our final answer when we factor. In this example, it's actually example 5 in your pre-reading for 7.1. We're taking the square root of 320 x squared y cubed c to the fourth. We have an even index, so 2. So we're going to think out some values that will come back to 320 and to work that out in your margin. And what we would get is the square root of 8 squared times the square root of 5. So think that through. That look like 320. So this time we worked a bigger value with a smaller exponent. And then we would have this happening. So we know if this one is right away. We can kind of mental math on while we're looking at it. We try to match our exponent to our index, and we're breaking apart this y cubed into the square root of y squared times the square root of y. Still the same value as y cubed. We just broke it into a value that we can use, and we're going to leave our c to the fourth power because it has an even exponent alone for now. Alright, so factoring this out, we can address this, 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 and this outside the root symbol right away. So 2 divided by 2 would leave 8. And 2 divided by 2 would leave x. 2 divided by 2 would leave y. And 4 divided by 2 would leave z squared times the square root of whatever's left, 5, and y. Alright, so these x and y terms have an invisible math exponent of 1. That is an odd exponent. You have a rule that outside the square root, if you have an odd exponent, those values have to be in an absolute value symbol. So we actually would just put those in the absolute value symbol outside the root. So don't forget to do that. Okay, in our next example, we have a cubed root of 24 x to the 6th power, y to the 7th power, z to the 10th, r to the 13th. So this 24 is easy to break down. We can have the cubed root of 8 times the cube root of 3. And then we'll leave x to the 6th alone because it has an even exponent. We'll break out the y exponents for the cubed root of y to the 6th, cubed root of y, and then we're going to break out the z, so it's a cube root of z to the 9th times cube root of z to the 1st, and then we're going to have times the cube root, ran out of room, of r to the 12th times the cube root of r to the 1st, or the r to the 13th. Alright, so we factored out exponents that would be divisible by our index of 3, and then address the remaining value. So right away, for the cubed root of 8, we get 2. The cubed root of 3, we can't address right now. 6 divided by 3 here leaves an x squared. So we've addressed these two. 6 divided by 3 leaves a y squared. And can't address this one right now. 9 divided by 3 leaves a z to the 3rd power. Address that. And then 12 divided by 3 leaves an r to the 4th power. We address that one. And it's all going to be times the cubed root of any value left over. So we have 3 y z and r. Okay. Notice that outside our root, z to the 3rd power has an odd exponent. That needs to go into an absolute value symbol. Don't forget that. So address that after you evaluate your exponents outside the root symbol. In the 4th root of 32, x to the 7th, y to the 12th, z to the 15th, and r to the 20th, in in much the same way, we can start to factor and say the fourth root of 16 times the fourth root of 2 times the fourth root of x to the fourth times the fourth root of x to the third times the fourth root of y to the 12th, we're going to leave that one alone, times the fourth root of c to the 12th times the fourth root of c to the third, ran out of room again, times the fourth root of r to the 20th. We're going to leave that one alone too, because those exponents divide evenly by our index 4. All right. So the fourth root of 16 is 2. So we address that. We're going to leave this one alone. 4 divided by 4 here leaves x. 3 and 4 we can't divide, so we're going to leave that one alone. 12 divided by 4 leaves 3, so we have y to the third. Address that one. 12 divided by 4 is z to the third. So we address that. We're going to leave this one alone, and 20 divided by 4 is r to the 5th. Outside the root symbol, inside the root symbol with the index of 4, we're going to address, we have a 2, an x cubed, a z cubed, and we've already addressed the r to the 20th power. So we've addressed everything. Notice our odd indexes, our odd exponents here, here, and here outside the root symbol. So to address those, they will go in absolute value symbols. All right, number 20. We're going to do number 20 in your assignment and number 34. Not sure if that was on the original slide. Number 20 is a cubed root of 405 a to the 4th power b times c to the 3rd power. So if we think this through, if you take 3 times 3 times 3 times 3, then all of that times 5, you're going to come back to the 405. So you're in this territory, you're looking for these kinds of values in your margin as you're factoring these out, getting back to what that would look like in the root situation. So we would have the cubed root of 3 to the 4th power times the cubed root of 5 times a to the 4th. Well, we're going to do the cubed root of a to the 3rd times the cubed root of a times the cubed root of b We're going to leave the cubed root of c to the third power alone. Breaking this down further, we can take the cubed root of 3 to the third power times the cubed root of 3 to the first power times the cubed root of 5 times everything else that we just factored to break the front part up. So that leaves us with 3 here, A here, and C here. Times the cubed root of 15, A, B. Your book doesn't annotate that this should be an absolute value, but we have a 1 exponent outside the root. It is an absolute value if you have an odd exponent. All right, so just remember that outside that root symbol. Okay, number 34. You're given plus or minus the square root of m plus 9 to the 4th power. Remember your index here is 2. So to simplify this, just say 4 divided by 2 here. It'll drop your square root, retain your plus and minus, and you're going to get m plus 9 squared. I hope this helps, and I'll see you soon.